Welcome to biotechnology class. In the previous class, we highlighted what biotechnology can do and the aspects of biotechnology. And one aspect we notice is the cell and tissue culture technique. Generally, biotechnology can be broadly divided into cell and tissue culture technique, enzyme technology, and genetic engineering. Cells and tissues can be cultured as batch and continuous cultures. In batch culture, an inoculum of cells from a pure culture is introduced into a fresh suitable nutrient medium and incubated under appropriate conditions. All the cells introduced in that kind of system have the potentials to grow at a very rapid rate. This growth, which is an orderly increase in all the compounds of the organism, is associated with multiplication by binary fission. That is, a single cell will divide into two, and subsequently the two cells will divide again, and as the division continues within the suitable nutrient medium, if the number of cells present at different time after inoculation is measured and the logarithm of the number of cells is plotted in relation to time, that is the period of growth, the resultant plot is referred to as a batch growth curve. A process where reactants, that is nutrients, cells, and probably gases are brought together to induce a spontaneous reaction. The batch culture system is a closed system, except for possibly gas flow. The batch culture involves a system where no new nutrients are added to the system and no metabolic wastes are removed. As metabolic wastes accumulate, the cells may eventually stop growing. Especially when the nutrients are exhausted. Typically, the plot of the logarithm of the number of cells in base 2 with time will give us the typical growth curve, which can be divided into the lag phase, the exponential or log phase, the stationary phase, the death or decline phase. In the lag phase, there will be no increase in cell number. Individual cells will increase in size, absorb nutrients, and increase in size because the cells are physiologically active and probably synthesizing new enzymes to enable them adapt to a new environment, a process of acclimatization. In the exponential or log phase, there is condition of balanced growth. Cells most nearly uniform in terms of chemical composition and metabolic and physiological activity and efficiency. And the increase in number of cells is exponential. At the stationary phase, at this phase, accumulation of toxic metabolite and exhaustion of nutrients have set in. Some cells will start dying while others continue growing and divide. And the assumption is that at this stage, the number of viable cells may become level off. And after that, the system moves to the decline phase or death phase, where further accumulation of inhibitory metabolic products occur and depletion of essential nutrients. And the number of viable cells will decrease exponentially. And all cells typically will die within days to months. The next kind of growth is what we call continuous cultures. Recall that in batch cultures, nutrients are not renewed and growth will remain exponential for only a few generations. But in the continuous culture system, microbial populations or cell populations can be maintained in a state of exponential growth over a long period of time by using the system of a continuous culture. In continuous cultures, nutrient medium is continuously added and the spent culture continuously removed from the culture vessel. And this continuous addition and removal of spent culture, addition of nutrient medium and continuous removal of spent culture results in the achievement of a steady state in which the viable population of cells is constant because the removal of cells as the exhausted nutrients are removed is balanced by new cell growth from the addition of nutrients. In the continuous culture, the growth chamber is connected to a reservoir of sterile medium. Once growth has been initiated, fresh medium is continuously supplied from the reservoir. The volume of liquid in the growth chamber is maintained at a constant level by allowing the excess volume to be removed continuously through a siphon overflow. Usually, the fresh medium is introduced at a constant rate. And with that, the density of cells in the growth chamber remains constant after an initial period of adjustment. What it means is that the organisms in the growth chamber just grow fast enough to replace those lost through the siphon overflow. Then again, if the rate of entry of fresh medium is changed, another adjustment period occurs, followed by maintenance of constant population of a new density. Therefore, the rate of addition of fresh medium determines the rate of growth of the culture. The continuous culture system is self-regulating. The continuous culture is in the form of chemostats or turbidostats. In chemostats, the introduction of nutrients helps to monitor the growth of culture, and the culture adjusts to the flow rates of these nutrients. In the turbidostat system, is designed to include the optical sensing device, which measures the absorbance of the culture density. And this helps in maintenance of steady states in the continuous culture system. So when you look at the diagram of the continuous culture system displayed, the chemostat and the turbidostat. Let's start with the chemostat. You will see where the sterile medium reservoir is placed, and there is a flow regulator that regulates the amount of fresh medium that gets into the culture vessel. And you will see a sampling outlet, and it is at that same rate of flow in of sterile medium that spent culture is allowed to enter into the spent culture bottle. You will also notice that there's a constant level device. In the turbidostat, you will also observe a reservoir of sterile medium, and you observe the constant level device and the turbidity of in the tank or growth vessel is detected, and fresh reservoir flows in, and at the same rate the spent medium leaves the culture vessel. The continuous culture system is useful for the study of microorganisms because they provide a constant source of cells in the exponential phase of growth. They allow cultures to be grown continuously at extremely low concentrations of substrates. Remember that The key differences is that in the batch culture, no new nutrients are added, and it is a closed system, while the continuous culture, fresh nutrients are added and is an open system. The continuous culture provides continuous source of cells at the exponential phase, whereas the batch culture, the growth is in phases: the lag phase, the log phase, the stationary phase, and the decline phase. The practical advantage of continuous culture is that at that growth of organisms at low substrate concentrations, we can study regulation of synthesis or catabolism of the limiting substrate in selection of various classes of mutants. And this is useful in ecological studies. Thank you for listening to this lecture.